Okay, I did recommend making a list of the tools that you have, the concepts, the ideas that you have to pull together. And if you had a list and you're reading it, the word kinetic energy theorem, which ought to be fresh in your mind, it probably is because it came up, would be right there, right? And if you got that list, of course, you don't get to carry that list into a test. You don't want to pull that list out in the lab. You don't want to pull that list out when you're discussing the thing with somebody else. Those things have to be there. Okay? So our question is, if you do work W in a system, what's the change in omega? And what should come out of your head is, when you see the work done on the system, and let's call this network. Then you know that that's equal to the change in kinetic energy, right? So your reasoning process, well, okay, or the work you do, you know, okay, so you got the change in kinetic energy. Okay. And I asked what's the change in omega? Okay. That really wasn't the greatest question to ask, because as we worked out before, change in kinetic energy gives you a change in omega squared, if you know what it is. Okay. So, your network is your change in kinetic energy. From mass configuration, you could find the change in omega squared. If we're talking about this system, where you just have a mass at a certain distance, okay? Implicitly, when we're talking about a mass, a point-like mass at a distance r from the axis of rotation. That's kind of implicit when we did this, okay? Didn't want to confuse the issue at this point with a lot of detail. But for a mass at a distance r from the axis of rotation, and I'll even put point-like in here at this point. Meaning the mass can be treated as if it's all concentrated in one specific distance. Okay. A point like mass at distance r from the axis of rotation. Find a change in d squared, okay? So, back to our, just an example, 100 gram mass. 30 centimeters from the axis of rotation. Let's assume delta W net is 5 joules. Okay? Okay, well, half the mass is 50 grams, which is 0.05 kilograms. Okay. 0.05 kilograms into 5 joules is 100. Right. It's going to be meters squared per second squared, so we get 100. Okay. On the circle, meters along the arc.
Yeah, literally. Where'd he go?
Is approximately 32 radians. What do you think about why that is? Yeah. Circle's about a third of a meter in radius. If you divide the 100 meters along the arc by a third of a meter, you get as I said, about 320 radians. Okay? And it might be more closer, 320, 330 rounded to the nearest 10, somewhere in there. And I think it's actually going to be 330. So anyhow, you correct that, but it's 320 radians, okay? And really, that's worth thinking about. Really what I want to do is this, so put that square meter in there, okay? So 1 meter along the arc is 3.2 radians. Well, this is meters along the arc, right? So that tells you you have 100 times 3.2 radians quantity squared. Okay. So that's going to be about 1,000 radians squared per second squared. Okay. 3.2 squared is clear close to 10.
Oh, 3.2.
Okay? Now, that's not a change in angular velocity, that's a change in squared angular velocity. If you want to get the change in angular velocity, you got to know what angular velocity you started with. Okay? So like if you started at 0, your change would be 1,000. Okay? That'd be your change in omega squared. Okay? So omega squared goes from 0 to 1,000 radians squared per second squared, right? Depending on omega, you have to go from 0 to the square root of 1,000, around 30 radians per second. If you started at 1,000 radians per second, or 100, let's say start at 20 radians per second, then your omega squared is 400 radians squared per second squared. And the change by 1,000 is going to go up to 1,400, right? At 1,400 radians squared per second squared, your angular velocity is the square root of that. Okay, about 36, 37 radians per second. Okay? Now, there are easier questions I could have asked. I asked you to change the omega squared. I could have given you the initial omega here and done that. Okay? It probably would have, so I accidentally wrote down what's a change in omega and that thing. But again, you see how everything follows up to here, and everything follows up to here. The basic principles. Okay? So, there we have it. Put some problems down and we'll see you in lab on Friday.